Hello and welcome back to Big Discussions. My name is Dr. Anwar Youssef Dunbar. I am the owner of this channel and I'm also the founder of the Big Words blog site. All of the information from my blog can be found on the banner for this channel, in addition to all of my social media contact information. Today is June 8th, 2018, and I want to first start off by thanking everyone who has subscribed to this channel, everyone who has liked my video content, and for those of you who have shared it. All these things are very, very important for my growing the channel. The videos being liked, and particularly the videos being shared. All this is very important, and I appreciate you watching me, and I appreciate the new subscribers. This week I've had about 5 to 6 new subscribers, so I'm steadily building and growing momentum here. Let's see. So I've been wanting to make this video, or should I say I've been wanting to start this series for a while. I started the channel in January of this year, and it's been one big experiment. It's been a constant learning and growing process. And you know, one of my main motivations for starting this channel and even writing some of my blog content is, well, actually, let me go back to the beginning. I'm actually working on a book right now, and my overarching goal has been to build an audience. That's why I started writing for Examiner.com, and when that closed, that's why I set up the Big Words blog site, because I wanted to continue to build an audience. And that's why I ultimately started this YouTube channel. But in addition to building an audience for my book, I wanted to reach back and help out individuals who I thought I could impact, or whose lives I thought I could impact. And so as a Black STEM professional, one of the things that I've learned is that there aren't a lot of us. So less than 10% of STEM degree holders, science, technology, engineering, and mathematics, less than 10% of STEM degree holders look like me. So I thought it would be valuable and worthwhile to make myself present and visible in this way, because I could easily go to my job every day as a regulatory scientist, work in my cubicle, perform my duties, and then just come home and keep all this information for myself. But in my opinion, for the coming generations, particularly in the Black community, we need to be visible. There are lots of images of celebrities and athletes and entertainers in other professions like lawyers and those kinds of things, but the mainstream media is not showing enough Black scientists. We do see Neil deGrasse Tyson, who rebooted Cosmos, but we need to see, I think we need to see more Black scientists talking about the science, sharing scientific ideas, and discussing why these careers are important, and why this knowledge is important, and why these skill sets are important. So that's why I'm doing what I'm doing. So please share this video to any young person or any family who you think could benefit from it, because there are a lot of Black families that don't have any STEM professionals in them. So those kids, most kids are going to pretty much grow up doing what they see or doing what they emulate. So if they don't have any STEM professionals in their families, they're going to be less likely to follow that track. So I'm going to get off my high horse now. So what I wanted to do, and what I did on the Big Words blog site, was I created a series looking at some of the stems that I was trained in, which would fall under the biomedical sciences. And I wanted to kind of, because I get the questions a lot, what's a regulatory scientist? What is pharmacology? What is toxicology? What is inhalation toxicology? What is ADME / drug metabolism? So I get those questions a lot. So I wanted to kind of package those in a very understandable way for the laypersons, and I wanted to basically set the stage up for me to share this information and also talk about it. And maybe at some point I can get out from in front of the camera and actually go out and speak. One of my goals is to actually, at some point go out and speak about these things. So I think the way that I wrote the series up was that I did pharmacology first, and then toxicology, and ADME / drug metabolism, and then inhalation toxicology, and then I got into regulatory science and the basic sciences and basic research and the applied sciences. But to do this on video now, I think the most appropriate way is to talk about the basic sciences first and basic research first. So that's what this first video in this series is going to be. So as I was thinking about doing this, once again I heard my brother Amal Dunbar's voice, and we've actually made 2 videos together, one reviewing Avengers Endgame, and then we did something together at the Maker Faire, at the Northern Virginia Maker Faire last week. So my brother is an advocate for things being short and concise, and I realized that the way the blog post about the basic sciences and basic research, I realized that the way that it was written up, I kind of hit both of them there, but for a video, there are actually 2 stories. So for this first one, I'm just going to talk about what the basic sciences are in a very general way, and then I'm going to follow that up with a discussion about what basic research is. So for those of you who have science backgrounds, a lot of this is going to be review, but for the laypersons and people who don't have a scientific background, this is going to be a nice comprehensive introduction to why I'm going to talk about some of the sciences I was trained in more detail. So this is going to be just a general introduction. So when I wrote up that blog post about the basic sciences and basic research, I did a quick Google search to look up the basic sciences, and it brought up 4: physics, biology, chemistry, and mathematics. And what's interesting is that I never considered mathematics to be a basic science, but I guess in today's thought process, it's considered one of the basic sciences. And as you'll see, it should be right there with the other 3, because it permeates all 3 of the others. So you can't do physics, you can't do chemistry, and you can't do biology without some form of mathematics, because ultimately you're quantifying things, and you're doing experiments, and you are generating data. So with that, let's jump in. My goal here is not to be fast, and as I actually have to run off to a meeting, but let's jump right in. So I'm going to start with physics, and again, this is review for the science people out there. So physics is I'm going to talk about this first because it's considered the grandfather of the other sciences. Physics is not a science that I understood right away, and I actually made a video on it talking about my early struggles in physics, because I didn't understand what was going on. Physics is a highly quantitative science. And basically, all physics is we're coming up with mathematical explanations for how to understand our physical world. And so I actually gave a discussion about this at a career day I did yesterday. And so you're looking at, you're trying to explain gravity, what's holding us in place. You're a good example of that is the space shuttle here. Just to design this space shuttle and to have it launch from Earth and go into outer space, that required, something like that requires a lot of calculations. You have to figure out the mass of this shuttle. You have to figure out the amount of force you need to get this shuttle to overcome gravity and go into outer space. You have to figure out how to get the shuttle back into the Earth's atmosphere. You have to figure out how quickly or how fast this shuttle is going to move once it gets into outer space. So there are a ton of things that you have to understand about the physical world just to launch a space shuttle. The same is true for an airplane. The same is true for a train or a metro or a helicopter. Physics, in some instances, we're talking about time. For example, when astronauts go into outer space, time is different because there's less of a gravitational field. In physics, you're looking at how quickly or how fast the planets in our solar system are orbiting our star, our sun. You know, it in astronomy and astrophysics. Well, that's all physics. Astronomy is all physics, is all in that. This cell phone, and you have a cell phone, you have an Android or an iPhone. There's a lot of physics that has gone into the designing of this cell phone. I was telling a bunch of students that I recently spoke to that there's a wave, or there are waves going from this cell phone to the tower. This phone is powered by a lithium-ion battery, so you're looking at the movements of charged particles and electrons and those kinds of things. So physics it's everywhere, and it impacts everything, as you'll see. So let's go back to our space shuttle here. Let's talk about chemistry. You know, you can't make a space shuttle made out of paper. You know, a lot of research and knowledge of chemistry goes into designing a durable shuttle that can stay together as it lifts off from the Earth's surface and going into the harsh conditions of outer space. So chemistry, you're thinking about atoms and molecules and how those all fit together. You're thinking about reactions, combustion reactions, synthesis reactions, hydrolysis reactions, all kinds of reactions. You're thinking about biological molecules like DNA, proteins, lipids, sugars, those kinds of things. You're thinking about what things are made up of, what to make buildings out of, how to make the rails for trains so that they can sustain large variances in temperature. So chemistry is everywhere. In a lab setting, if you're doing basic research, which I'm going to talk about in the next video, you're making solutions and reagents in the lab. That's all chemistry. Many of the products we buy, whether they're healthcare products or beauty products or gardening products, that's all chemistry. So that's all chemistry is explaining atoms and molecules and how various reactions go and how substances around us fit together and why they have the properties that they have. That's chemistry. If you notice, now let's talk about biology. I'm not wearing my Michigan pharmacology shirt, so I'm going more general. So biology is the study of all things living, all things containing DNA, all things with carbon-based molecules. So as I described in one of my earlier videos, and I'll probably put all these things in the description box so you could watch, my first scientific interest was not in pharmacology. It was in life science, which was in the 7th grade. And what you'll find with all of these basic sciences is that there are so many other sciences that fit in under them. So there are numerous disciplines that fit in under physics. There are numerous disciplines that fit in under chemistry, such as chemical engineering and organic chemistry and physical chemistry. So for biology, it's the same thing. There are the biomedical sciences, there are agricultural sciences, there are environmental sciences, and so there are numerous scientific disciplines that fit just under this one science. And I'm going to talk about some of the biomedical sciences coming up in future videos. But just suffice it to say that this deals with all things living. And one could argue that medical doctors, well actually no, medical doctors are scientists as well. Their focus is on treating disease, and they focus on patient care. So they're scientists as well. But there are other scientists like pharmacologists and toxicologists who focus on how to make those medicines and what doses of those medicines are excessive and too much. So the biomedical sciences. So there's pharmacology, there's toxicology, there's genetics, there's virology, there's biochemistry, microbiology, physiology. So there's a whole slew of sciences that fall under the umbrella of the biomedical sciences. And the biomedical sciences falls under biology. And then and there are the plant sciences. I don't think I said the plant sciences, and that's very important as well. And then there's mathematics, and mathematics is pretty straightforward. At an early age, we start learning addition and subtraction, multiplication and division. And then as you go on, it gets steadily more complex to the point where you're doing decimals and fractions. And then, you're doing exponents. And then eventually you're getting into algebra, trig, and then you're going into calculus and all those kinds of things. And again, mathematics is essential because you can't do physics, chemistry, or biology without it. And as I'll describe, because I'm going to describe pharmacology, toxicology, drug metabolism, and inhalation toxicology, and I'm going to show you how physics and chemistry actually impacted my research, and how many of the tools that we use to do biology involve physics, chemistry, and mathematics. So those are the basic sciences. I'm going to stop this here. the next video will get into what basic research is, because that's, even though, even while I pursued my PhD in pharmacology, I did not understand what that term was, basic research. And I heard it when I was in someone's office one day talking about my future plans, and I never heard the term before. But it's an important term, and it's not well understood, and I think it will set up other discussions for me and others to have. So I'm going to stop here. Those are the 4 basic sciences. Thank you for watching. Please like, share, and subscribe to my channel. And please share this with someone if you think they can benefit from it. These are important terms, and knowing about these sciences can unlock doors for others to advance themselves and participate in these highly important STEM careers now. But you got to understand the basics first, and why they're important, and how science impacts us in our everyday lives. So watch out for the next video. And I'm going to close a little bit differently this time. I've been thinking about other things to make my channel unique, and I'm going to close with a specific quote, and I will probably return to this quote numerous times in the future, because it involves the book I'm writing, which I'm going to talk about some more in the future as well as I get closer to finishing it. But a mentor once told me that your attitude determines your altitude. So that just might become my signature close for my videos. So thank you for watching, and I'll see you next time. And always remember that your attitude determines your altitude. Take care. Bye-bye.